Hey everybody, this is Mr. Munson again, and we're still in Unit 2, circles, and today we're looking at 2.6, arc lengths and sector area. And so one of the coolest applications of this is a piece of pizza, not because you actually use the application of this section on it, but looking at pizza is always good. And so feel free to put me on pause and stare at that piece of pizza, but if you're ready to get going, let's get moving. Okay, so we're ready to do your vocabulary. Please put this on another piece of paper. Proportion, it's an equation or a relationship between two fractions. And so you can see an example of that. And then in the far right-hand corner, I give you two fractions, and I remind you, and you can put these in your own words here, cross multiply. If you have two fractions that are equal to each other, you cross multiply. That's why it says 2 times x, 5 times 3. You just simply solve that. Let's look at the next. Cool, just a reminder of pi. Pi is 3.14. At any point, put me on pause, write this stuff down if I get too fast, too far ahead of you. Circumference. Circumference is defined as the distance around a circle. So here's a circle with a radius of 3 meters. Basically, circumference equals 2 pi times r. Now, we're going to have that on our formula sheet, so make sure that you're creating your formula sheet. In just a moment, I'll go through some more formulas. They're going to be appearing here on the definition page, just kind of a reference, but your formula sheet has to have it on there as well. Right? Area of a circle. So an area of a circle is the math of how many squares it takes to cover a circle. So if I was to draw, and get my pen ready to go here, if I was to draw, come on, here we go. If I was to draw stripes on this, right? Okay, and then stripes going this way. Those are the squares, and so some squares are full squares, some squares are parts of squares. But if I wanted to know how many squares it takes to cover something, I would use area. Okay, so here's the area formula again. You're going to see that on your formula sheet in just. So next up is arc length. That's the length of an arc. So if I was to take a look at this arc to highlight, you see it there in yellow. I want to know the physical length of that. In the past, up to this point, we talked about the measure of that, which is completely different. The measure is equal to 65 degrees. Okay, but the length of that arc is how many inches, how many feet it takes to walk from one spot of the arc to the other side of the arc. Okay, and so we're going to have a formula for that. You'll see it in just a moment. Okay. Last up is sector area. It's the number of squares it takes to cover a sector or a wedge of a circle. Left that word off of a circle. Okay, so basically it's the piece of pizza, right? So I'm looking to cover this part right here. It's the number of squares it takes to cover that, okay? Known as area. Up next is formula sheet. Again, another piece of paper. You should have a continuing formula sheet from the very beginning of this year. And so if you don't have that, find somebody. Get it fixed up. First up is circumference. So I have a circle of 3 centimeters. Circumference, the number of that is 2 pi times 3 in this case. Hey, I want to point out something. This is the reason why you're writing these equations. There's 1, 2 unknowns in there. So I could actually give you the circumference, this number, and ask you to find this number. Okay? So you need to know both left and right, so you have both pieces to solve for it, the missing stuff. Next up is the area of a circle. And so basically that's area equals 2 or a pi r squared. So in this case, the r is 6, and so we would square that, making it 36 pi. So I could certainly take 36 and multiply it times pi, but there's going to be problems where I'm going to say leave it in terms of pi. That's what I mean. You're not going to multiply it times 3.14 or whatever. You're just going to leave it as 36 pi. All right, arc length. We already know what it's defined as. It's the length around it, but this is the formula for finding it. We have the measure of arc AB. The measure is in degrees. So make sure you give yourself a note there. This is in degrees, like 36 degrees, whatever. That portion of the is so many degrees out of 360. Okay, so that fraction, however many degrees the arc is out of 360, has to equal the physical length of the arc, 3 meters, whatever, out of the total amount of circumference. So if you look at the bottom, we have total amount of degrees and total amount of distance. On top, we have a part length and a part degrees. Let's look at the red work over here. We have just an example setup of the problem. We have a 60-degree angle, 44 meter or centimeter radius, and I just plugged the information in. This is getting ready to solve. I have no unknowns in this except for the length of the CD. So it's set up to solve that problem. Let's move on to the next one. All right, last but not least, sector area. So this is the pizza problem. So here's the formula for finding sector area, the amount of squares it takes to cover your piece of pizza, right? And so it's the measure of arc AB, that would be again in degrees, out of 360 degrees. And then the sector area would be out of the total circle's area, pi r squared. So here's an example setup. I have a 75-degree central angle. That certainly means that the arc on the outside is 75. So we know it can go back and forth. And then we have a 5, whatever, we'll call it centimeter radius, and I just plug the information in. This equation right here is ready to go for finding the sector area. Again, this is on your formula sheet so that you can go back and find your formula and then an example setup. Let's look at your note. All right, it says I can find one of your I can statements on your sheet is I can find the circumference of a circle. This is a repeat of previous material, so I'm going to go through this really quick. All right, because it gives me that AD is the 12 centimeters, I know that's the full diameter. So for the circumference, I need to know what the radius is. Okay, so let's go ahead and just plug in the information, calculate what the circumference is. I have 3 numbers here. I have 2, pi, and 6. I can multiply them in any order I want to. So I'm going to do the 2 and the 6 together. Okay? And that gives me the circumference, the distance all the way around the circle, to be equal to 12 pi centimeters. These units, because it's distance, matches these units because it's distance. That's the distance of the diameter. So it might ask me to, put my answer in so many decimal places or whatever. If it does, then it's great. If it says leave it in terms of pi, we are done. This is equal to or approximately equal to 37.7. So I'm going to put squiggly lines, 37.7 centimeters long. Okay, very good. That's the distance all the way around. Now, just for the sake of time, we're not going to have you do an example problem of that. You need to make sure you're taking good notes on this so that when you get to the try it problems, you can look at that model and apply it. Or any of the problems that we're getting ready to look at the try it problems, they match the example problems I'm giving you. So you make sure that you're taking good notes and you apply what you need to. All right, so I can find the area of a circle. So I'm going to need the area formula. All right, go ahead and see if you can set this problem up and then check your work, put me on pause, come back to me. Okay. Keep in mind that area is the art of finding out how many squares it takes to cover a circle. After putting this information in, I get that it's 144 pi centimeters squared. That's kind of a weird way of expressing the number of squares. So it might ask me, to go ahead and round that to so many decimal places. And there you have it. It's approximately 452.4 centimeters squared. So if I wanted to go out and buy tiles to cover this circle that are 1 centimeter by 1 centimeter size, right, I would buy about 453 of these, maybe 460 or 470, because I'm going to break some of them. So anyway, moving on. All right, here we have another one. This is kind of the beginning of new stuff. We have the measure of APB. The angle APB is 135. So the first thing I would want to do is put that information in there. And that the radius is 12 centimeters. Just put that as a radius. And every one of these radii are equal to 12 centimeters, right? So now it's saying find the length of AD. Okay, the physical length of that, not in degrees, but in centimeters. So I'm going to have to look back at my formulas, go see if you can figure out which one it is you need to use, and then see if you can set it up properly. Put me on pause, see if you can set it up, and if you have trouble even solving for it, just start me back up and see what I'm doing. Okay, since it's asking me to find the length of an arc, I need to have that as one of my unknowns. This is the equation I want to do. So again, if you had to sneak a peek to see which equation I'm going to use, this is the one. If you had to sneak a peek on that one, then see if you can put me on pause again and start putting in the numbers yourself and see if you can figure it out. All right, so the arc that I'm looking for here is this red-blue one, and so I need the angle for that one. And so I did some math down here below. It equals 45, and I'm ready to start setting this up. So I'm going to choose to just put a y in for the arc length, and then when I'm done, I'll go back and call it the arc length. But I'm ready to start working this. Do a little cleanup, and then next step, since I have a proportion, I have a fraction equals a fraction, I'm going to cross multiply. Okay, divide both sides by, whoops, divide both sides by 360. And let me just help you process that. What I'm going to do is take the 360 and divide it into 1080 and kind of see it as this problem. Okay, the pi can come down to the side, and we take the numbers and divide them out, and I end up with 3 pi equals y. Okay, so let's go and finish this out and have a final answer. All right, it comes out to be an arc length of 3 times pi, or 9.4 centimeters. Okay, let's go on. All right, here's one to find the area of a sector. Again, go back and look at your formulas, see if you can figure out which one you need to do. See if you can set this one up on your own. If not, come back and see me and watch my work. Well, actually, you kind of have to know which is the shaded region. So let's shade a region and see if we can find this out. All right, there you have. So now go ahead and put me on pause and see if you can set this one up. Let's clean it up a little bit. Let's go ahead and cross multiply. Notice I'm not going to multiply the pi. If I throw the pi in there, it's going to turn into a nasty decimal. But also, sometimes it might say, give me the answer in terms of pi. As soon as you see that, you never want to multiply through by the pi. Otherwise, you lose the pi in the number. You want to keep it out, just like I'm going to do in this problem. Just like that. So now what I'm going to do is divide both sides by 360. And like in the previous problem, I'm going to take that 360 and divide it only into that first part, the number part. That'll keep the pi from coming into the problem. I'll just put the pi off to the side. Okay, so after I do that 4,860 divided by 360, I get 13.5 pi centimeters squared. Don't forget your units there, okay? It'll be wrong. And this is approximately equal to 42.4 centimeters when I multiply it through by pi. Okay, let's move on. Okay, so here in this I can statement says I can find the radius of a circle given its circumference or area. So I'm going to just kind of set up some problems here and show you how with those equations, the circumference equation, the area equation, there's unknowns in there. If you fill in a couple of the unknowns or fill in the unknowns, whatever's left over is one that you can solve for. Hopefully you understand that statement after you watch the next few minutes. So once I put the information in, then I'm left with only one unknown, and that's r. So I'm going to start solving for that r. Okay, so I just solve for that. Hey, notice the 2 pi's on the left-hand side of the equation actually cancel out, and the 2 goes into the 24. It leaves me 12. But now I don't have any units of this. I want you to look up the information and see if you can figure out what units I should have. Hopefully you saw it as centimeters. So here's the thing. I might have said, hey, find the radius, right? That's what actually that's what I did. I said find the radius. But suppose I didn't say that. Suppose I gave you the same information above and I said find the area, right? So you jot down the area formula like I have here to the right. But see, the area formula doesn't have a place for circumference. So what your problem skills would need to be is, hey, you know, in order to use the area formula, I need to know the radius. So as we just took the circumference and found the radius, your problem solving skills need to be such that you say, well, first, to answer in this problem, I'm going to have to go find the radius by using the circumference formula, right? And then once I found r, then I could plug that into the area to find the area formula to find the area. All right, hopefully you've taken some good notes. Okay, here's your try it problems. And so go ahead and work on those. Notice in problem number 2 at the bottom it says leave in terms of pi as explained in the video. Okay, so if you're not sure what that means, you need to go back and look at the video and see where I talked about leaving your answers in terms of pi. The first one I want you to go ahead and multiply through by pi, so you'll have a big long fat decimal and you're just going to round that to the nearest hundredth. That's it. See you next class.